Hi, this is part 2. If you haven't seen part 1 yet, I certainly recommend that you do that first. We join our lesson, already in progress. The x value at negative pi, which is negative 1. All right, now we're going to do something a little bit different. This time, we're given the trig function, and we're given its value, in this case, square root of 3 over 3, as you can see. And we're asked to find the value of t. In other words, what value of t makes cotangent square root of 3 over 3? Well, let's refer to the unit circle chart in quadrant 1 chart and find cotangent theta at square root of 3 over 3. Okay, well, you can see above that's at pi over 3. And since this is a quadrant 1 chart, t is in quadrant 1, then we found the value pi over 3. And we write t equals pi over 3. Don't write just pi over 3. Make sure you write t equals pi over 3. Okay, well, here are two more examples where the cotangent is square root of 3 over 3, but this time in part B, we're given a different kind of restriction. We're told that the t is between 0 and pi, and that means that t must be somewhere in quadrant 1 or quadrant 2. Because cotangent's positive, that must be quadrant 1, right? And the quadrant 1 value we saw in the previous example is pi over 3. So again, t equals pi over 3. In part C, we have a different restriction. This time the restriction is between pi and 2 pi. Well, that is quadrants 3 and 4. And because cotangent is positive this time, we must be in quadrant 3. And we're looking for the pi over 3 value in quadrant 3, and that is 4 pi over 3. So that's the value of t. T equals 4 pi over 3. All right, in this example, notice it says that t is in quadrant 2, so we can see where it is that we're working. And we're told that tangent of t is negative 1. So we don't focus on the negative, we focus on where tangent is 1, and it's at a pi over 4 value. That's the pi over 4 radian value. And in quadrant 2, that is 3 pi over 4. So t equals 3 pi over 4. In this example, we have an unusual restriction, pi over 2 to 3 pi over 2. Well, that actually starts at the top of quadrant 2 and ends at the bottom of quadrant 3. So we're talking about values that are in quadrant 2 and quadrant 3. Now notice that tangent is negative, so that must be quadrant 2. And in quadrant 2, the pi over 4 value is 3 pi over 4. So again, t equals 3 pi over 4. All right. This time we're told to work in quadrant 1, and cosecant of t is equal to 2. On our unit circle chart here, cosecant is 2 at pi over 6. So in quadrant 1, it's going to be pi over 6. T equals pi over 6. Let's remember that because we're going to use that in our next example. This time, our restriction is that t is between 3 pi over 2 and 5 pi over 2. Well, that's actually quadrants 4 and 1. Starting at the bottom of quadrant 4 at 3 pi over 2, coming up all the way to 5 pi over 2, which means we've actually passed through 2 pi. So 3 pi over 2 to 2 pi to 5 pi over 2, quadrants 4 and 1. Cosecant of t is equal to 2. and it is positive in quadrant 1, and that occurs at pi over 6. However, because it's beyond 2 pi, we actually have a value of 13 pi over 6 for t. T equals 13 pi over 6. It's 13 pi over 6 because of the restriction. This time we're asked to find cosecant of negative square root of 2 when t is in quadrant 4. But in general, cosecant is square root of 2 at pi over 4. So we're going to focus on the quadrant 4 value in pi over 4, which is 7 pi over 4. Okay, fairly straightforward. T equals 7 pi over 4. In this next example, cosecant of t again is negative square root of 2. But this time the restriction is from negative pi over 2 to positive pi over 2. And that's at the bottom of quadrant 4 at negative pi over 2. And as we progress up towards pi over 2 at 90 degrees, we actually go through 0 first, and then we get to pi over 2, quadrants 4 and 1. Because cosecant is negative, it must be in quadrant 4. So again, the pi over 4 value in quadrant 4 is 7 pi over 4. Wait a minute, that doesn't seem quite right. No, we have to be between negative pi over 2 and positive pi over 2. Well, that means that, yes, it's the same location as 7 pi over 4, but it's not the same value. It's coterminal to 7 pi over 4. It is actually negative pi over 4. That is the radian value between negative pi over 2 and positive pi over 2. Same location, coterminal with 7 pi over 4, but 7 pi over 4 is not the answer. All right, in this next example, we are in quadrant 3, and the sign is negative, negative 1/2. Well, that's easy to find on our unit circle chart. Sign is 1/2 at pi over 6. However, in quadrant 3, that's 7 pi over 6. So t equals 7 pi over 6. Okay, well, this time we have a restriction between negative 3 pi over 2 and negative pi over 2. Negative 3 pi over 2 is located where 90 degrees is, and negative pi over 2 is down at 270 degrees. And as we draw the arc that includes those, it goes right through negative pi, and that's quadrants 2 and 3. And let's see now, sine here is negative, negative 1/2. That must be quadrant 3. Okay. Well, in quadrant 3, sine is negative 1/2 at 7 pi over 6. But wait, again, not 7 pi over 6 because that doesn't fit the restriction. Instead, it's going to be a negative number. And if we just kind of add a little bit more to this circle and do the negative pi over 6 in quadrant 4, we find that negative 5 pi over 6 is in quadrant 3. And that is the actual answer for t. T equals negative 5 pi over 6. Okay, this time sine of t is negative 1. Again, from negative pi over 2 to positive pi over 2. Starts at negative pi over 2, goes through 0, all the way up to positive pi over 2. But it actually isn't in any quadrant. It's an axial value. Let's see, sine of t is negative 1. It is down at the negative pi over 2 location. T equals negative pi over 2. This time tangent of t is negative 1, but it's the same restriction, starting at negative pi over 2 and going up through 0 and ending at positive pi over 2. So we have the negative values in quadrant 4 and the positive values in quadrant 1. So tangent of t is negative, first of all, and that's going to be in quadrant 4. And tangent t is 1 at pi over 4. So the value we're looking for in quadrant 4, that's at pi over 4, would be 7 pi over 4. Again, that's actually not correct, because we see that it's got to be a negative value between negative pi over 2 and 0. So the coterminal value that's negative is negative pi over 4, and that's the value of t. Okay, now we're going to look at trigonometric functions in function notation. And I had this reminder from algebra what a function notation looks like. It's f of x equals 3x minus 5. And in place of x, we might put a 2. Of course, we could put all kinds of numbers, but we might put 2 and get 3 times 2 minus 5, which is 6 minus 5, which is 1. And so I have an input of 2 and output of 1. We could say that f of 2 equals 1. Well, we're going to do the same thing now for trig functions. So this time, given that g of x is equal to 3 times tangent x, we're first going to find g of pi over 6. In this case, that means 3 times tangent of pi over 6. We look up the value for pi over 6, discover that it's square root of 3 over 3, or maybe we have it memorized. That's terrific. Of course, the 3 can be written as 3 over 1, and because we're multiplying, we can divide out the 3's in this case and get just square root of 3. G of 3 pi over 4 means we'll put 3 pi over 4 into the function. So it becomes 3 times tangent of 3 pi over 4. That's 3 times negative 1, which is negative 3. And then g of pi means we'll put pi into the function. So that's 3 times tangent of pi. Now tangent of pi is 0. So that becomes 3 times 0, which is 0. Let's look at another set of examples. This time our function is h of x equals secant of 3x. And we're first of all going to find h of pi over 4. Well, that means secant of 3 times the x value, pi over 4, which becomes secant of 3 pi over 4. And that value is in quadrant 2, it's negative, and at pi over 4 it's radical 2, so we get negative square root of 2. In part B, h of pi over 3 is secant of 3 times x, 3 times pi over 3. Well, those 3's divide out right away, and we get secant of pi, and that's negative 1. All right, well, here comes a little more challenging function. K of t is equal to the cosine of t minus pi over 3. K of 5 pi over 3 means we'll put 5 pi over 3 in place of t. It gives us cosine of 5 pi over 3 minus pi over 3, which is cosine of 4 pi over 3. And let's see, that's in quadrant 3, which is negative, and the pi over 3 value for cosine is 1/2, negative 1/2. In part B, k of 7 pi over 6 means we have cosine of 7 pi over 6 minus pi over 3. Ooh, to subtract, we need common denominators. So let's do that off to the side here. Common denominator of 6, so 7 pi over 6 minus pi over 3. We'll multiply that by 2 over 2. That'll get us a common denominator so we can subtract. Let's see, that's 7 pi over 6 minus 2 pi over 6. And that gets us 5 pi over 6. So the argument simply becomes 5 pi over 6, and we get cosine of 5 pi over 6. and that is in quadrant 2, so it's negative. And cosine of pi over 6 is square root of 3 over 2, so we get negative square root of 3 over 2. Let's do the same for k of negative pi over 6. That goes in the first value, cosine of negative pi over 6 minus pi over 3. Again, we're going to have to get common denominators, so negative pi over 6 minus pi over 3 times, we'll multiply that by 2 over 2, and that gets us negative pi over 6 minus 2 pi over 6 is negative 3 pi over 6. Oh, that nicely simplifies to negative pi over 2. And the cosine of negative pi over 2 is, that's at the bottom of the y-axis, that's 0. All right, so that's my lesson for the day. I hope this makes sense, and I'll see you next time. Bye-bye.